I want to thank everyone for coming out today. My name is Drew Manley,
I'm Thomas Passion.
I'm on campus.
Kevin Wood.
and this semester we work with Bowman Consulting. Our site is located in Stafford, Virginia. And our mentors were Chuck Fitzgerald and Bill Pyle. We were instructed to design a 4-story Hilton hotel. It was a little over 60,000 square feet, and it was going to occupy about 100 rental units. The site total was about 3 acres, and it was zoned B2 urban commercial. The site was pre-existing conditions were mostly undeveloped, except for a small residential unit with a gravel driveway leading from Jefferson Davis Highway. We had a few restrictions with our site. We had to take into account a 50-foot RPA, 100-foot RPA, and a 100-year floodplain. So that made it difficult since we were going to be dealing with a 3-acre site. They pretty much cut it in half, so we were working with about 1.5 acres. This is our site, this is the outline. And on the right side is Jefferson Davis Highway. We were allowed to build within the 100-foot RPA, our main structure, but nothing else. Within 50-foot RPA and the 100-year floodplain, we were only allowed to have the entrance from Jefferson Davis. The parking requirements, we had to have 100 parking spots because we had 100 rental units in the hotel. This is our first design, and we decided that this was not an efficient design because, first of all, we could not meet the parking spaces, the parking limit, and second, our flow of the parking lot was just not efficient. So we decided to go with our second design here. And as you can see, we moved the main structure of the building towards the eastern side of the site, and the entrance was moved up to the top northeastern part. You can also see we only have the building within the 100-foot RPA, and it's right along the line of the 100-year floodplain.
So at this point, we got some feedback back from mentors, and we realized we misread the architectural designs, and the entrance wasn't where we thought it was. This led to having to reshape the entrance to the whole site so that the drop-off area for the hotel could be proper. And then that led to moving the entrance. The relocation of the loading space had to be moved because originally it wasn't near the site, so that wasn't feasible. They needed to be right next to the hotel so that they could load all the stuff they needed. The kind of curved area you saw in the previous design got turned into a rain garden. And then, how I said earlier, since the entrance was moved, we managed to move some parking lot around. And then for the grading, we basically started with the building pad. We set the building pad elevation to 65 feet, and we kind of graded out from there. Since the site was relatively small, we just had to ensure that slopes were fine. And then there is one part that had a steep slope, and that was the connection to the adjacent site. This later got fixed on with some retention walls. And then at this moment, we currently only have one retention wall, which was on the northern section of the site. And then the parking lot slopes were 5% longitudinally and 2% across. And then this was our new design. How I said, this would be the new entrance right here, and we moved the entrance farther down. The rain garden will be in the top, you can see in the middle of the parking lot. And this provided a smoother drop-off area and ensured that the whole parking could be accessible.
Yeah, one element of this project was that between every element we constantly consider a mentor's comments and revise the design. So one thing that happened between grading the LM and the stormwater one was we realized that we needed to not grade out to the RPA. So we ended up putting retaining walls all the way around the site. This is kind of a significant change. It didn't change really the grading within the site, but that was something I'd like to point out. We calculated the volume of the detention basin using the GeoPhysics methodology. Using the pre and post development flows, we found the time of concentrations for them and found pre and post development flows of approximately 4.21 cubic feet per second for the pre-development condition and 15.83 for the post development. Based on that, we found we needed a storage volume of approximately 71,000 cubic feet. based on just the limitations on our site imposed by the RPA, and just like the fact that we basically took up all the rooms and grade, and we realized we're going to have underground storage, so we chose an underground storage method. We ended up using the RTAC underground storage basin system. If you want to go to the next slide, and this is what a picture of it is. They're almost kind of like Lego blocks that you lay down. They have some interior structure, so they don't quite have 100% capacity, of the overestimate the volume a little bit. But they enabled us to basically shape the underground storage in any way we wanted to, which is beneficial since we had kind of a funny site design. We ended up using these. We ended up laying out. If you want to go to the next one. Sorry, this is just an example of our pre-development time concentration. Next one. And then our post. Okay. So what we have here, sorry. Here we have our detention basin laid out, and we ended up extending it along the length of our site. This allowed us to sort of reduce a lot of the pipe network we had to install. We ended up not having a full pipe network. We basically have going straight from the inlet to the basin. That simplified some of the things and allowed us to use smaller pipe diameters. Also, the length of the basin sort of allowed for potentially some slight water quality benefits, where the water would have a longer time to travel through before it came out here and ended up outfalling into our existing stream underneath our entrance bridge. The inlets and the water pipes are designed using the rational method. So we developed 9 different inlet watersheds. We ended up reducing it to 8 because we had an issue with the inlets near the entrance of the structure, the inlets near the entrance of the property. The slopes weren't working out. We ended up having to install a pump near there to get the waters back up to an elevation where they wouldn't backflow into the inlets. We ended up removing that, so we're back down to 8 inlets. So that's basically the method we had to go through. We ended up using a total of about 4,446 of the cubes for the detention basin. Another thing that we did, there's all these interesting things we've done on this site. We have this long length here you see between basically these parking spots and the drive aisle. It goes all the way up there, and it gets very flat here. There's essentially no slope. So we ended up putting a 3-foot wide porous pavement strip all the way along the length there, kind of overlapping half on the parking and half on the drive aisle, and then putting a 15-inch perforated stormwater pipe in there, wrapped in cloth and then in stone. And so basically it acted almost like a long extended inlet that would capture the water and allow it to not basically pool up on the road before winter inlet. We also had the rain garden, as you can see here, which acted as like some extra storage and potentially some water quality benefits.
Okay, so I'm going to talk about the erosion and sediment control plan. The phase 1 of the plan involves 2 diversion dikes heading into a sediment trap, and a portion of that diversion dike is an underground 18-inch ductile iron pipe to allow for equipment to travel over the road without having to avoid a diversion dike there. There was super silt fence around all of the site that was not covered by the diversion dike. Super silt is preferred by Stafford County, which is why we use super instead of silt fence. And you can go ahead to the next one. So this is the phase 1 plan. Our diversion dikes, we have one heading along this way, another one heading this way into the sediment trap. If the sediment trap overflowed, it would go into the creek at the southeast of the site. And our construction entrance was at the northeast of the site there. Go to the next slide. And then for phase 2, basically what we do is remove the diversion dikes in the sediment trap. And we actually move the construction entrance, if you go to the next slide, down to where the site would actually have the entrance onto the property in the parking lot. And silt fence was kept to remain protecting the sites next to our site, as we're not allowed to affect the resource protection area or the sites next to us. So you move on to what utilities or cost system.
So our cost estimate for the final cost came out to about 1.2 million. All this was estimated using the Prince William County land development unit prices. And then for the porous pavement and the R blocks, we actually contacted ASFE and got a quote from them depending on the size that we were using. And here at the end we have some visual layouts of our site. Down here you would have the Jefferson Davis Highway and the actual building. That would be the actual entrance looking at it from Jefferson Davis. And then here we have kind of two close-ups of the rain garden. This would be from the northern section of the site looking down toward the entrance. And then that's kind of the whole main site. Do you have any questions?
Yeah.
Do you guys know if there'd be any structural problems having a basin that size for your parking lot?
Pardon me. These basins, they kind of have an interior structure, and they were actually designed to go under parking lots in a lot of cases. Most of the examples we saw were already under parking lots, so we weren't really concerned with that. We also made sure that there's enough depth. So there's like about a 5-foot depth difference between the top of the surface and the top of the basin. So we figured that would help sort of spread out some of the stresses.
Yeah.
Said there's only 100 spaces required for the 100 rooms. What are the workers and staffs this work?
I think that was just from Stafford County Code. It just says minimum, it's one per room. I assume that takes into account everyone else.
And that was fortunate because we had exactly 100 spots. We may have been able to like squeeze one more out.
Ideally, we're guessing Stafford County is not a tourist destination.
So I do.
All right, in the interest of time, I'm going to have to let these guys off the hook early.